Download this code from codegive.com, link in the description below. OK, let's dive deep into router sleds, addressing common mistakes and how to avoid them, so you can achieve perfectly flat and even surfaces for your woodworking projects. This guide is geared towards evening woodworkers, assuming you have some basic woodworking knowledge but want to elevate your skills with this incredibly useful tool. What is a router sled and why use one? A router sled, also often called a router flattening jig or router planing jig, is a jig designed to hold a router and guide it across a surface, removing material evenly. It's used for flattening warped or twisted slabs, ideal for leveling the faces of live edge slabs, tabletops, and other large, irregular pieces of wood that are too big or awkward for a jointer or planer. Creating consistent thickness, achieving a uniform thickness across a wide board or panel. Resurfacing workbenches, re-establishing a flat, level working surface on your workbench. Working with difficult grain, sometimes it is safer to route a board with figure or knots because there is no risk of tear out. Creating perfectly parallel surfaces, for projects that demand precise alignment. The anatomy of a router sled, general design. While there are many variations, a basic router sled consists of the following. 1 base, or rails. 2 long, parallel pieces that provide a stable and perfectly level surface for the sled to slide on. These are critical for the accuracy of the whole jig. 2 bridge, or carriage, a piece, or sometimes 2 pieces, often connected with additional supports, that spans between the base rails. This is where the router sits and moves. 3 router base, a flat piece of material, often plywood or MDF, attached to the router. It increases the router's footprint for stability and slides along the bridge. Common router sled mistakes, and how to avoid them. This is the heart of the matter. Let's break down the common pitfalls. 1. Unstable/unlevel base rails. The problem if the base rails aren't perfectly parallel to each other, flat, and at the same height, the router will cut at an angle. This defeats the purpose of flattening. Imagine building your house on a crooked foundation. The solution. Material selection. Use a stable, straight material for your base rails. Kiln-dried hardwood, like maple or oak, is ideal, but high-quality plywood or MDF can also work if they are thick enough to resist bending. Avoid framing lumber, 2x4s, etc., which can be twisted. Jointing/planing. If using solid wood, joint one face and one edge of each rail to ensure they're perfectly flat and square. Then, plane the opposite face parallel to the first. If using plywood or MDF, check the flatness with a straight edge. Leveling. Place the rails on your workbench or a flat surface. Use a long level, 4 foot or longer, to check their levelness. Shim as needed with paper shims or thin wood strips until both rails are perfectly level with each other. Secure mounting. Once leveled, securely clamp or screw the base rails to a stable surface. Don't just let them float, as they can shift during the routing process. Code example, concept, measuring rail height. Explanation. This is a conceptual code example. In reality, you don't program your sled, you build and level it. But the concept of measuring and comparing rail heights to a tolerance value is how you would verify the rails are level. 2. Flexible bridge/carriage. The problem. A bridge that flexes under the weight of the router will cause uneven cuts. The center of the slab will be higher than the edges. The solution. Sturdy material. Use thick plywood, MDF, or solid wood for the bridge. The thicker and more rigid, the better. Asterisk reinforcement asterisk add supports or cross braces to the bridge to prevent flexing. For example, if using a single plywood bridge piece, add 2 or 3 pieces of lumber underneath, glued and screwed in place, running perpendicular to the bridge. Asterisk minimize span asterisk keep the span of the bridge, the distance between the base rails, as short as possible while still accommodating the width of your workpiece. A shorter span is inherently stiffer. Asterisk test for flex asterisk before starting to route, place the router on the bridge and apply some downward pressure. Watch for any noticeable flexing. If it flexes, add more reinforcement. Asterisk code example, concept, deflection calculation, simplified. Asterisk explanation asterisk this code example illustrates a simplified engineering concept, beam deflection. It highlights that a longer bridge, length, and a lower moment of inertia, less stiffness, will result in greater deflection under load. While you won't directly calculate deflection, the concept should inform your design choices to create a stiff and robust bridge. 3. Router base instability asterisk. Asterisk the problem asterisk if the router base, the piece that sits on the bridge, is too small or not perfectly flat, it can wobble or tip, leading to uneven cuts and potential gouging. Asterisk the solution asterisk. Asterisk large footprint asterisk make the router base large enough to provide a stable platform. A circle or rectangle at least 8 to 10 inches in diameter/width is a good starting point. Asterisk flat surface asterisk ensure the router base is perfectly flat. Use a precision level to check. Asterisk secure attachment asterisk attach the router securely to the base. Most routers have threaded holes in their base for mounting. Use these if possible. If not, you may need to carefully drill and countersink holes. Make sure the screws are flush with the base. Asterisk smooth edges asterisk round over or chamfer the edges of the router base to prevent it from catching on the bridge. Asterisk consider bushings asterisk you can use bushings around the router bit if you are wanting to use the same setup for different size slab jobs. Asterisk code example, concept, stability check. Asterisk explanation asterisk this code illustrates the principle of stability related to the area of the base. A larger base means less pressure per square inch, which is generally more stable. It's not directly used in sled operation, but informs the design choice of having a larger router base. 4. Inaccurate/wobbly router bit asterisk. Asterisk the problem asterisk a dull, bent, or poorly secured router bit will create a rough surface, uneven cuts, and potentially dangerous situations. Asterisk the solution asterisk. Asterisk sharp bit asterisk use a sharp and appropriate router bit. For flattening, a slab flattening bit or spoiler board bit is ideal. These are typically large diameter with replaceable carbide inserts. Asterisk secure the bit asterisk make sure the router bit is securely tightened in the collet. Use 2 wrenches to tighten it properly. Asterisk clean the collet asterisk regularly clean the router collet and the router bit shank to remove any dust or debris that could prevent a tight fit. Asterisk check for runout asterisk check for runout, wobbling, of the bit. If you see excessive runout, replace the collet or the router bit. A dial indicator can be used for precise measurement. Asterisk appropriate RPM asterisk run the router at the correct RPM for the bit and the material you are cutting. Large diameter bits should be run at lower RPMs. Refer to the bit manufacturer's recommendations. Asterisk code example, concept, RPM calculation, very basic. Asterisk explanation asterisk this is a very simplified example and should not be relied upon for real-world RPM settings. It demonstrates the concept that larger diameter bits generally require lower RPMs. Always refer to the bit manufacturer's recommendations. 5. Excessive cut depth asterisk. Asterisk the problem asterisk taking too deep of a cut in a single pass can overload the router, cause tear out, and potentially damage the bit or the workpiece. Asterisk the solution asterisk. Asterisk shallow passes asterisk take shallow passes, typically no more than 1/8, 3 mm, per pass, and even less for harder woods or figured grain. Asterisk multiple passes asterisk be patient and make multiple passes to gradually remove the material. Asterisk listen to the router asterisk pay attention to the sound of the router. If it sounds like it's struggling or bogging down, reduce the cut depth. Asterisk climb cutting asterisk be very careful with climb cutting. It can be dangerous if not done correctly. Conventional cutting is usually better for routers sleds. Asterisk code example, concept, cut depth control. Asterisk explanation asterisk this code shows the concept of breaking down the total material removal into multiple passes based on a maximum cut depth. You don't program your router to do this, you manually adjust the router height and make multiple passes. 6. Unsecured workpiece asterisk. Asterisk the problem asterisk if the workpiece isn't properly secured, it can shift during routing, leading to uneven cuts and potentially dangerous kickback. Asterisk the solution asterisk. Asterisk secure clamping asterisk use a combination of clamps to hold the workpiece firmly in place. Use non-slip pads under the workpiece to prevent it from sliding. Asterisk hot glue or double-sided tape asterisk for smaller or awkwardly shaped pieces, hot glue or double-sided tape can be used to temporarily secure them to a sacrificial surface. Asterisk consider dog holes asterisk add dog holes to your workbench and use bench dogs to help hold the workpiece. Asterisk stop blocks asterisk use stop blocks to prevent the workpiece from moving in the direction of the cut. Asterisk code example, concept, clamping pressure, very simplified. Asterisk explanation asterisk this conceptual code demonstrates that total clamping force is proportional to the number and strength of clamps. While you can't easily quantify it, the underlying idea is that more and stronger clamps provide better workpiece security. 7. Dust collection issues asterisk. Asterisk the problem asterisk routing produces a lot of fine dust, which can be a health hazard and obscure your view of the cut. Asterisk the solution asterisk. Asterisk dust collection asterisk use a dust collector connected to the router. Many routers have a dust port. If yours doesn't, consider using a dust boot around the router bit. Asterisk shop ventilation asterisk ensure good ventilation in your shop. Open windows and doors, or use an air filtration system. Asterisk respirator asterisk wear a respirator or dust mask to protect your lungs from fine dust particles. 8. Poor planning and setup asterisk. Asterisk the problem asterisk rushing into a project without proper planning and setup can lead to mistakes and frustration. Asterisk the solution asterisk. Asterisk visual inspection asterisk thoroughly inspect the workpiece for any defects, knots, or other issues that could affect the routing process. Asterisk plan the cut asterisk plan the order of cuts. Determine how much material needs to be removed from each side of the workpiece. Asterisk dry run asterisk do a dry run, without the router turned on, to check the movement of the sled and ensure there are no obstructions. Asterisk mark reference lines asterisk mark reference lines on the workpiece to help guide your cuts. 9. Ignoring grain direction asterisk. Asterisk the problem asterisk cutting against the grain can lead to tear out, especially on figured woods. Asterisk the solution asterisk. Asterisk observe the grain asterisk carefully examine the grain direction of the wood. Asterisk cut with the grain asterisk whenever possible, orient the workpiece so that you're cutting with the grain. Asterisk shallow cuts. Asterisk take very shallow cuts when cutting against the grain to minimize tear out. Asterisk sharp bit. Asterisk a very sharp bit is especially important when cutting against the grain. 10. Assuming perfection, without checking. Asterisk the problem. Asterisk assuming that your setup is perfect without actually verifying it can lead to cumulative errors. Asterisk the solution. Asterisk regular checks. Asterisk regularly check the levelness of the base rails, the rigidity of the bridge, and the tightness of the router bit. Asterisk test cuts. Asterisk make test cuts on scrap wood to fine-tune your setup before working on the final piece. Asterisk measure frequently. Asterisk use a straight edge and feeler gauges to check the flatness of the workpiece as you go. Don't wait until the end to discover that you have an uneven surface. Building a simple router sled, example. Here's a simplified example to illustrate the basic construction. Remember, this is just one approach, adapted to your needs and available materials. 1. Base rails. Asterisk use 2 pieces of straight, kiln-dried hardwood, example maple, oak, plywood, or MDF. For example, 2x4, actual dimensions 1.5 x 3.5, x 8 feet long. Ensure they are perfectly straight and coplanar. 2. Bridge. Use a piece of 3/4 thick plywood or MDF that is long enough to span the distance between the base rails plus a little extra for overhang. For example, if the distance between your rails is 24, make the bridge at least 30 wide. The depth of the bridge should be enough to allow the router to move across the full width of your workpiece, example 12 deep. Reinforce underneath with lumber. 3. Router base. Cut a circle or rectangle from 1/2 or 3/4 plywood or MDF that is large enough to provide a stable platform for your router. Attach the router securely to the base. 4. Assembly. Securely clamp or screw the base rails to a stable surface, ensuring they are level and parallel. Place the bridge across the base rails. Slide the router, with its base attached, along the bridge. Important safety considerations. Eye protection. Always wear safety glasses or a face shield when routing. Hearing protection. Wear hearing protection, as routers can be very loud. Dust protection. Wear a respirator or dust mask. Secure workpiece. Ensure the workpiece is securely clamped. Keep hands clear. Keep your hands clear of the router bit at all times. Unplug when adjusting. Always unplug the router before making any adjustments or changing the bit. Read router manual. Read and understand your router's instruction manual. In conclusion, building and using a router sled is a valuable skill for any woodworker. By understanding the common mistakes and following the solutions outlined in this guide, you can avoid frustration and achieve perfectly flat and even surfaces for your projects. Remember to take your time, plan carefully, and prioritize safety. Happy rooting!